Alright, we're going to look at inequalities with absolute value. Recall that when dealing with equality, we said that absolute value of x equals 1 can mean one of two things: x equals 1 or x equals negative 1. Now we have a similar thing that's going to happen with inequalities. In this case, we're going to look at what does that mean. So if we change this to the distance language, it says what points are at distance 1 or less from 0. So if you had to show that in a number line with a diagram, you would say that points that are at distance 1 or less from 1 are between -1 and 1. Okay, in the interval notation that we have learned, that would be -1 to 1. In the same way, if the distance is to be greater than 1, then there are a bunch of other points for which this is true, namely anything more than 1 and anything less than -1. So in that case, in the interval notation, it would look like -infinity to -1 union 1 to infinity. Okay. Now these can be translated as compound inequalities. For example, the fact that x's absolute value of x is less than or equal to a can be written as x is less than or equal to a and greater than or equal to -a. And this can be written as x is greater than or equal to a and less than or equal to -a. So notice how the set of directions for these are the same. These are both left facing, these are both right facing. So caution, anything of this form where, see, they are both less than, so they convey the same information, so this is never going to happen. The only two situations are both left facing or both right facing. Now let's look at an example. So here this would simplify to less than or equal to 3 and greater than or equal to -3. Consequently, we would add 4 to isolate x to get x less than or equal to 7, greater than or equal to 1, which makes it between 1 and 7 and everything in between, or in interval notation 1 comma 7 square bracket. So any one of these representations are fine. Let's look at another example. In this case, instead of less than, it's a greater than, but we still maintain the symmetry with the +5 and -5 and the direction pointing to the right. We subtract 3 to get 2x greater than or equal to 2 and less than or equal to -8. Divide by 2 to get x greater than or equal to 1, less than or equal to -4, which makes it -4, 1, everything more than 1, everything less than -4. In the interval notation, that's -infinity to -4 closed union 1 to infinity closed at 1. So it's this or this or this. Let's look at a slightly more complicated example. Now here, to be careful, the absolute value term is this and not all of it. So in order to simplify it as compound inequality, I first have to isolate that part, meaning I first subtract 7 and now I divide by -2, keeping in mind that division by negative numbers flips the sign to 10. Once you have that, now this is in the form that we are familiar with, namely 3x plus 5 less than equal to 10, greater than equal to -10, subtract 5 on both sides, -15, 3x, 5, divide by 3, x less than equal to 5/3, greater than equal to -5. Now here it's not symmetric, right? These are different numbers. So let's interpret these results properly. It's greater than -5 and less than 5/3, so it's in between them, right? So that's an acceptable representation. Or you can have -5, 5/3, both closed. Okay, that's the last example I have here. So that's where we are going to end with absolute value inequalities. Thank you.